Now we will move on to our next speaker of the evening, Lovee Jain, presenting on the topic Serverlessing Like a Pro. Lovee Jain is a senior software engineer with a passion for user-centric technology solutions. She excels in full-stack development, cloud computing, and UX design, aiming to create integrated platforms with optimal user experience. As a Women Techmaker Ambassador and GDG Melbourne Co-Organiser, Lovee actively promotes diversity in tech through speaking engagements and community leadership. Her dynamic career showcases a commitment to innovation, collaboration, and empowering others in the tech industry. Please welcome her with a round of applause. Yeah, that's my pleasure. Now you know. Sorry, I am messy. You all know that.
Anyone for a screenshot? Go and check.
Who's the photographer? Please don't click that. Cool. Okay. I think I'll be doing some demos and I think I'll be changing screens and things, but that's okay. All right. So hello, everyone. I am Lovee Jain, and as messy as you saw my desktop, I'm not that messy. But anyway, I'm a senior software engineer at Prezzee, Women Techmakers Ambassador, and a Google developer expert, and a GDG Melbourne Organiser. So, and tonight I'll be talking about serverlessing like a pro. So what we have on the agenda is we are going to talk about what is serverless and then straight away get into creating a function. And then we are going to talk about what is beyond functions, look at a couple of use cases, and then I've got a little Memo demo for you, and then we are going to close with some best practices. So before I start, I'd like to gauge the audience. How many of you here have provisioned or managed servers before? Not many. Oh, okay. They're coming up slowly. So how many of you here are starting with cloud and have heard of serverless? That's cool. All right. So serverless, does that mean no servers? Not really. There would be still some servers, but you wouldn't be the one managing or provisioning them. It would be done for you by your cloud provider. Over a period of time, there has been a shift observed towards increasing the focus more on your business logic rather than the underlying infrastructure. So earlier, when we used to have physical servers, we had to manage or configure those servers, the environment, the operating system, networking, patching, and everything. And these physical servers, they would always run, even when not in use. So you would be paying for an idle time. And then came virtual machines. They were really good at the resource utilization. However, you would still have to manage the environment, the operating system, everything else. And then came containers. So how many of you have here heard of Docker? Yeah, okay, pretty much everyone. That's good. That's good to hear. Anyway, so Docker popularized this concept of packaging your application and deployment code with dependencies so that it can be run as a container on any infrastructure. This was a huge improvement. However, when it came to scaling, it was a bit of challenge. And then your containers, again, they keep on running. Solution? Serverless. Now, with serverless, it actually abstracts away all the underlying infrastructure so that you can focus on business logic. So if your business logic is all about adding to numbers, that's all you focus on. You really don't care what machine it's going to run, how it's going to run. But what you do care about is where it is going to run, because you want your code or your application deployed close to your customers. So that's your responsibility. So what are serverless functions? Serverless functions are a single purpose modules of code. They can be triggered or invoked instantly with events. What kind of events? They could be, say you make an HTTP request. So that would be an HTTP triggered function. Say you want your function to be running every day at 2 p.m. That would be a timer triggered function. Or you can have custom events such as you uploaded an image on a cloud storage or an S3 bucket. So that is what is triggering the function. And once your function is triggered, it can do this processing. So for example, say it's going to update a database. Once it has done its processing, it can then vanish away. You can even have logging in your functions so that you can understand the behavior of your function, debug it, optimize it. So let's discuss some pros and cons of serverless functions. Pay-per-use. Now, as I mentioned, your function triggers instantly. It does this processing, and then it vanishes away. So you only pay for the resources that you have used. Your functions can automatically scale based on demand, ensuring smooth performance under spikes. Now, given you don't have to worry about the underlying infrastructure, you can focus on your business logic. It allows your business logic or your applications to come to market really quickly. So offers faster time to market. You can write your functions in so many different languages. It could be Go, Java, JavaScript, Python, C#. There's so many options. And then again, because you're not managing the infrastructure, it's managed by the cloud provider, you get good fault tolerance, and hence your functions are highly available. And obviously, there is better resource utilization. Talking about some cons though, because your function is not running all the time, there's a bit of a cold start. And in my experience, I have observed about 200 milliseconds of a cold start. So you might want to be a little careful when you are deploying your functions for a customer-facing application. There might be a bit of latency observed. Next, statelessness. Now, when you are calling your function, you can call your functions like multiple times, and all those requests or invocations, they wouldn't know anything about each other. So if there is a common context that you want to pass, it might not be shared because they don't know about each other. So there is a bit of statelessness there, but we are going to discuss more about it in our upcoming slides. And then finally, limited customization. Because you're not managing the infrastructure, you may think there might be limited customizations, but to be honest, in my opinion, even the limited options are so many, it doesn't feel really limited. But yes, if you have like very different demands, then yeah, you might feel that it's limited. Okay, so I think we have chatted enough. We should start creating a function. So we are going to create and debug an HTTP triggered function that is going to add 2 numbers, and we are going to deploy it from our local CLI. Now, before we do this, I'd like to mention that you can create functions either on console, or you can use text editor extensions. They are very powerful and very useful when you want to deploy any of the cloud resources for any cloud providers, to be honest. And then we can always do it locally, that we are going to do. And if you need further handholding, there's like advanced tools like Gemini or Copilot at your disposal. So yeah, it's gonna be very easy now. Okay, so let me try sharing the other screen. Okay. So what I'm going to do is I am going to straight away follow this documentation. Now, we are creating it on GCP, I just want to highlight the documentation just because so that you understand how easy it is to get started, how easy it is to go through the documentation. All you need to do is you need to select your project, and then you need to enable the APIs. You need to set up the Google Cloud CLI, and then obviously you need to have your node set up, and then you can even look at the sample code. So let's actually have a quick look at the sample code. So if you look at it, it's pretty straightforward, to be honest. And what I want to mainly highlight is actually, if you follow the breadcrumbs and if you go back a bit, you're going to find so many samples available. So if you want to get started with any of it, you can just go and check out these samples. They're very useful if you're just starting out your cloud journey. You'll be able to learn so many options, so many, with so many examples available. Alrighty, so I think I will duplicate or extend my display, or duplicate my display. Yeah, just give me one moment, because it's hard to. Yep. Okay. So, I see. Zoomed in enough. All right. So let's get started. We don't have to do much. I'm going to go to my favorite folder and create a new directory. There is demo functions. Can everybody see my screen? Or should I zoom in? Is this better? Yeah, okay. So I'm going to go to demo functions, and then all I have to do is npm init. It's a standard Node.js project. Not too much brains used. So yes to everything, and it's done. Let me open it in my VS Code. Oh, okay. Yeah, I renamed it. I know the code dot should work. It doesn't work for me for some reason. So I'm going to struggle here and open it. Okay. Zoom in more. This one. It's better. Maybe this is better. I'm going to create an index.js. And so if you saw the sample, it was pretty much straightforward. So the sample was in the functions here. So I have got a similar thing going on. I've already copied things, and I'm just going to copy it as it is. There you go. So what you do is you basically import a library, and then, oh, wow. See, the Copilot also explains what we are going to do here. And then you have, when you use functions.http, HTTP tells that it's an HTTP triggered function. Add numbers is the name of the function. You pass the request and response as parameters. You get the value of A and B from the body. And then finally, you get give the response. So, okay. Let's save this. And then instead of our standard start script, we have a different start script for our cloud functions. So I'm just going to copy this. And the target is basically your functions framework is using the Google Cloud's SDK and trying to use that to start your function. And then your target is basically add numbers. That's your function name. And the signature type is HTTP. Okay, so without any further ado, let's actually install this library or function. Yeah. Done, and npm start. It's running at 8080. So I have to zoom this one in as well. So I have got it at 8080. I've got the payload ready. And now I'm going to change this. Oh, change this to 10 and 25. Yeah, it knows how to add two numbers. That's great. Okay, now we know that it runs locally. It's time to deploy it. So, and you can also see it's printing it. So you can deploy your functions very easily with a little command here. So what it does is you use dcloud CLI, so I mean the Google Cloud, basically the command, and then functions, you are deploying add numbers. The trigger type is HTTP, runtime is Node.js 18, and you want to deploy a Gen 2 type of function. And it should start. It wants me to give it a region, so I'm going to give it as US East 1, just because it's my favorite. Not really. And then it's asking me if I want to allow unauthenticated invocations of new function. Yes, why not? Allow everyone. And it's going to start deploying. Meanwhile, it's deploying. Let's actually go to functions. So actually go to the console. That's what your GCP console looks like. You can look for functions, and you can go to cloud functions, and you would see that add numbers is now coming up. So if you go in here, it's a second generation function. There's some UI issues, I think. I saw this morning also, it was showing first, and then started showing second gen, but it's okay. And then you can look at all the, oh, it's not available. It's still deploying. Am I over time? Okay. All right. So these are the details. So you've deployed it in US East 1, and it's using a service account, and the memory allocated. This is the source code. You can edit the source code here. You can supply all the runtime, build environment variables, and even secrets. And this is the trigger. That's what we need. And then you can pass in more permissions. You can view logs, and then testing here. So let's actually change this URL to the URL that we have just got, and see if it is able to add numbers. Ta-da! It's working. So you've deployed the function. That was that easy, isn't it? Now my application is already in the market. So yay. So if you look at the logs, you would be able to see the sum. So that result at the end is 125. I ran it earlier just to make sure everything's working. So you would see all those other results, but the result is 125, and you can see it. So that was that easy to create a new function. So let's get back to the slides. And I would like to stop mirroring. Okay. All right, perfect. So I have been talking about serverless functions together interchangeably and all those things. But what is it really, serverless? It's more of a paradigm shift in how we build and deploy applications while abstracting away underlying infrastructure complexity. You can deploy an entire stack of services that can respond to specific events or requests. It can scale to 0 when not in use and scale up when increased demand, and for which you do not have to worry about the management and provisioning, and the billing is handled by the cloud provider. So what we have beyond functions is serverless databases and storage. So earlier, when we used to have like non-serverless databases, you have to specify how much you want to allocate. But with serverless databases, you don't really, you just still specify, but it still has automatic scaling, built-in replication, and global distribution. Then we have serverless containers. So we touched upon containers at the start of the talk, where we talked about the containers. They provide a lightweight and portable way to package application code and its dependencies, ensuring consistency across different environments. But the challenge was when it comes to scaling, because it required expertise in orchestration and resource management. But with serverless container platforms, they actually abstract away the complexities of managing the clusters and instances, so that when you scale automatically, you don't really have to do that orchestration. It's all abstracted away, and you can scale automatically or based on demand, and you only pay for the resources that you use. So if you are looking something to use in GCP, it would be your Google Cloud Run. In AWS, it would be Fargate, or Azure, it's Azure Container Instances. Then we have got serverless data processing. Now, there's a difference between storage and processing. What we are talking about here is ETL, or extract, transform, load workloads, data analysis pipelines, real-time processing, batch processing, simulations, and AI data model processing. Now, these kind of jobs, they consume a lot of CPU, memory, and execution time. With them getting serverless, it abstracts away all the complexities of distributed data processing, and you only pay for the resources you need. What you would be looking for in GCP would be cloud data flow, Azure, its data factory, Amazon, its Kinesis. And finally, serverless workflows that also offer low-code, no-code approach. Now, serverless workflows, they can automate complex business processes by chaining together various tasks and services, and all without managing servers. And it's very useful when it comes to building integrations. You can use a visual editor or declarative YAML syntax, and hence it allows you to go to low-code, no-code approach. In Azure, I think it's Logic Apps. In Google, it's cloud workflows. And in AWS, the most closest one would be step functions, just because it has a visual editor. So anyway, I talked about chaining. So let's actually focus more on that. Consider an example where I have a customer, and the customer adds a product into their cart. And as soon as they add the product to their cart, what I want to do is I want to send them an email saying, hooray, you've added this product to your cart. Now, I want to do this with serverless function. So the trigger would be them adding the product to their cart. As soon as they added the product to the cart, the function would run. Function would grab the information of the customer, information of the product. The next step it would do is create an email template. And the third step would be sending the email. Now, if my single function would be doing this, there's a high chance that it might actually time out. It's a lot of stuff. So what to do? We can actually break it into multiple functions, so that one function triggers the next function. The output of one function becomes the input of the next function. So what we are going to have is, now I'm going to go to the next slide, but I want you to focus here, not on the slide, okay? It's a challenge. Okay, so you actually add the product to the cart. This triggers your first function. Now, first function is basically grabbing all the details of the product and the user, which triggers the second function. And then it actually going to create the email template. And then it is going to trigger the third function, which is finally going to send an email. So this is actually how your chaining would work. Okay, I want you to focus here. So with chaining, what now you have achieved is moving away from statelessness to actually statefulness. So with statefulness, you basically have that context continued. So now with chaining, you have continued that context. Context is helpful to maintain session information between invocations, such as user authentication tokens, session IDs, or intermediate processing results. What you can also do is you can go fan in and fan out techniques. So where you would actually trigger multiple functions in parallel and wait for them to finish, and then aggregate the result and call another function. You can even have long-running functions. So for example, if there's a function, there's an application, external application that you're calling, and it's going to take really long. So instead of timing out, what you would do is you would redirect the client to a status endpoint. And then the client can poll that endpoint and learn when the operation is finished. Alternatively, if you do not like any of these approaches, you can always leverage in-memory caching solutions like AWS Elastic Cache or Google Cloud Memory Store or Azure Cache for Redis to temporarily store your cache full data and manage some state. Oh, by the way, you can implement webhooks in serverless. Now, talking about webhooks, let's actually come to the final piece of the puzzle, which is your event-driven architecture. Now, going back to our example where and the customer was adding the product to their cart. Now, they are going to add the product to the cart, but instead of triggering a function, it's going to publish an event on an event bus or topic. So within an event-driven architecture, the flow of data and control in application is basically driven by events. So the event would be published on the event bus or the topic. Now this event or topic would be subscribed by a function, which is going to see that, oh, an event is there. Let me consume it. It's going to consume it. It's going to grab the customer information. It's going to grab the product information. And then it's going to publish that information to another event bus or topic. Now, this second event bus that you see in blue, it's actually, maybe it has two subscribers. The one is a data processor. Maybe the data processor wants to know that information so that, they just want to know what all products are added to the cart or do something with it, right? And then there could be another subscriber to it, which is a template generator. And then it could be actually chained with the email sender. So you can actually mix and match. You can do whatever you like with it. So basically, the communication is done by consuming and publishing events. And it helps in creating loosely coupled architecture, which is much more resilient and scalable. So going on to some use cases, you can create microservices. So while you can build them using pairs or containers, Serverless has gained significant momentum given its attributes around small bits of code, inherent and automatic scaling, rapid provisioning, and a pricing model that never charges for idle capacity. Next, you can create fully featured APIs plugged in with an API gateway that brings additional security, OAuth support, rate limiting, and custom domain support. Next, BFFs, my favorite, backend for frontends. So it's not a backend, it's not a frontend, it's more like a thin layer that resides between a backend and a frontend. It acts as a custom backend for a particular kind of frontend. So you can definitely create those in service environments. Data processing, we already talked about this, ETL workloads, structured, unstructured data processing, image processing, OCR, etc. Stream processing with real-time data processing pipelines, IoT sensor data, financial market data, etc., etc. And then integrations. I want to highlight something about integrations. So it is super useful. So especially when you have like legacy applications to work with, it's very easy to communicate with legacy applications using these kind of integrations. I have an example. So we used to have a file on an SFTP somewhere, and we used to have to pick it up, clean, and add details to a database, transform it, and then we would used to put it back. And we used logic apps and functions to do everything, and it worked really well, and it worked on time and everything. So you can actually create those kind of integrations. And obviously, low-code, no-code approach, so empowering users to develop their own minor integrations, helping automating day-to-day tasks. And finally, generative AI. How can I miss this? So it's gaining so much popularity. So you can actually build and deploy AI applications without worrying about server maintenance. I think Google's Vertex AI and Amazon Bedrock both provide serverless experiences, allowing you to get started quickly. Okay, time to see some memes. Well, not really. What we are going to do is we are going to look at some memes, but what we are going to do is I'm going to put or upload that meme to a cloud storage. And then it's going to trigger a cloud function. Now, this cloud function, it's going to grab the image details and publish it on an image queue. Now, image queue is subscribed by the Cloud Run application. And the Cloud Run application, when it gets that image, it's going to use Cloud Vision API to understand what text is on the on that meme. If it finds words such as Google, GCP, AWS, Amazon, Azure or Microsoft, it's going to put those words or publish those words on Cloud Name Queue, which is subscribed by the Cloud Data Flow. And then the Cloud Data Flow will update the count of that word in the Cloud Sheet. Okay, without confusing you more, let's actually get to it. Okay, let me actually start mirroring again. It's easier. Okay, cool. We are mirroring now. So meme one has this disturbed anybody? So the keyword is AWS, and we are going to upload this meme on this storage bucket. Oh, I already have it. I did not clean it up. I was testing. Let me clean it. Cool. Oopsies. Cancel. Okay. How about that? Okay, so we have uploaded this. And what this has done is it would trigger my image queue function. And what this does is basically just takes the information and puts it on the image queue. So this is what it is going to, this is what it has. It has actually published that on one of the queues. So can you see it? Should I zoom in? Yeah, sorry about that. Okay. So now it has got the image queue and the cloud name queue. It actually uploads it on the image queue because I can't show you anything here right now, but it is actually consumed by the image processor, which is the Cloud Run application. And then it actually takes out the words and then prints them, prints them here, obviously, but it sends them into the other queue from which is subscribed by the Cloud Data Flow. This is what the Cloud Data Flow looks like. If you can see the visual editor, this is what it looks like. So I used YAML to create it. And then finally, this is what my cloud sheet looks like. And see, the count has updated to 1. Okay, let's actually do one more meme. So it has got both Microsoft and Azure. I hope it reads it twice and updates the count. Okay, so let's actually go back to the storage and let me upload it again. Okay, let's see it work in real time. Okay, it worked. Oh, let me zoom that one in. Ah, come on. Okay, one more meme, just because it did not show up properly. Who has done that? Like, seriously, who has done that? Okay, so that's GCP. And I'm going to upload that one now. And let me see, did that update the count twice? No, it didn't. It didn't read it twice. That's not on me. That's on Vision. Okay. We don't need that. Okay. Oh, sorry. Okay, file uploaded. Let's see if it increases the count. Yay, it did. Okay, so it works. All right, so that was it for the Memo demo. You can see me afterwards if you're interested in more developer memes. But until then, oh God, I have to stop mirroring. Okay, so All right, so some best practices, or just to conclude, focus on small single-purpose functions. You can actually write, so with the generation 2 or Gen 2 functions, or even in AWS, I think you can write long, big, chunky functions, but I prefer writing small single-purpose functions. Leverage the event-driven architecture and implement efficient monitoring and logging. I cannot emphasize enough. Carlos has already pointed that one out. And then utilize caching mechanisms and design for security. So I don't know if you noticed, we allowed the unauthenticated invocations. Don't do that. Don't do that in production environments. So yeah, always think about security first. Okay, thank you so much. If you have any questions, yeah. Any questions? Yes.
Because you mentioned having limited control over the info side of things. In the event of deployment failure, do the user receive as to what went wrong with deployment?
Yes. So you can always look at the logs and you would find why it failed, what happened. So yes. Yes.
So how long does it usually take for example, the name that you share, right?
Yeah.
So how long does it, do we know the time does it, how much does the time usually, could it be faster, optimized faster?
To be honest, for the demo, I wanted it to take that long. I'm moving it from here to there like this and trying to show Cloud Run, serverless function, and everything together, like the cloud workflow as well. So very honest, when I've seen that if you are running your function for the first time, there's going to be a lot more cold start. Like it takes really long, but then it gets warmed up. The resources are warmed up, so it becomes quicker. And yes.
I have 2 questions.
Yes.
First one was it EBG?
Yeah.
First, the first.
Yeah.
What exactly are you pushing? Like anything?
I just push like the image details. This is just for the demo, right? So I don't really push a lot of data. I just push like image details, where the image is, what the bucket is all about. So that, yeah, where it's located. Yes, yeah. And then the Cloud Run basically subscribes to it. So it grabs the image with the URL and everything. And then finally uses Vision API to read what the text on the image is.
My second question, that Cloud Run bit.
Yes.
If you have done that with a cloud.
For the demo. Plainly for the demo. I could have used Cloud Run function for sure, 100%. I just wanted to demo that, every aspect. So
I'm always curious about like when Cloud Run.
yeah, it's mostly considered like this. If you have more, something that it's more like containerized applications, you would go for Cloud. But with Gen 2, to be honest, functions becoming a part of Cloud Run, so you can still run functions, but I would still prefer Cloud Run in such cases. Yeah.
Is doing something a bit more complex?
Yeah, because you can still have it running, right, all the time, if you want. Yeah.
All in one method.
Yeah.
Normally you stick that
Yeah.
functions only deals with one method.
Oh, yes. Yeah, yeah, absolutely. Yes. You can have multiple methods too. Yep. Yes. Any more questions? Yes.
You talked about a lot of use cases for when to use functions or serverless.
Yeah.
What would be when would you not use functions or serverless? The traditional serverless or stick to Kubernetes?
Yes. So I think if you have, I'm sure you must have worked with monolithic applications. They still use non-serverless stuff. You have to create like a cluster or something and then use it. So yeah, continue using it. Yeah, if you're creating new microservices, definitely go for serverless. Yes.
From your experience from the demos, what would you say the most challenging resource to work with in the demo setup?
In this demo setup, I had not used the cloud workflow before. So I had used like logic apps in Azure before. Like I find the most easiest one is logic apps. The second one would be your cloud workflows, because it still has like a learning curve, because you're still doing YAML and you need to follow the structure. So it took me some time to get to it. Yeah.
More questions?
All right. Thank you.